Alright, here's 3.2, which is comparing and ordering fractions and decimals. So what we'll be doing is we get a bunch of fractions or decimals or a mixture of them, and we're going to try to put them in order from least to greatest, what they're actually valued. So first I want to define what a fraction is, an improper fraction, and a mixed fraction, what they are. We are familiar with fractions. You've got a numerator and a denominator. This is how many pieces we're talking about. This is what one whole thing is cut up into. So we've got 3 pieces of a whole thing, and then there's 2 that we're talking about, so this would be 2/3. The non-shaded area would be 1/3. 1 plus 2 is 3, which would be 3 the total pieces. But there's also such thing as improper fractions. So for example, an improper fraction, it will have a numerator that's bigger than the denominator. I'll say that again. The numerator will be bigger than the denominator in an improper fraction. So here we're talking, we've got one whole thing and it's broken into 4 pieces. But we're talking about how many pieces? 5 of them. So 1, 2, 3, 4. Now we're talking about a 5th piece. So this would be more than one whole thing. We'd have 1, and we'd also have this extra 1 piece, which would be 1/4. So we can say that 5/4 is actually equal to 1 whole piece. So we draw a large 1 in front. There's 1 whole piece, and then there's 1/4 of another one. Okay? So there's 1/4, so we go 1 and 1/4. So 5/4 and 1 1/4 are equal. I show this because sometimes I'll give you fractions that are mixed fractions, other times I'll show improper fractions, and you need to be able to compare those. So method 1 would be to use benchmarks. I'll explain what those are in a bit. We're going to order these fractions from least to greatest. Sometimes it'll be the opposite. Here we go. Now, fractions ordered using benchmarks, we kind of set up a number line where we have different portions in between. So we have 0 and we have 1, and we know that halfway between would be a half. If we need to, we could go further and put in a quarter over here and 3/4 over here, and keep splitting them up as much as we need to be able to determine whether these are in different orders. Now, looking at this, we see that we've got 3/20ths, we've got 22/40ths, and we've got 19/20ths. These are the same denominator, so maybe we could change this one to be the same. If we can't, then maybe we could change these to be the same, and then it's easy to compare. Another way we can do this is we realize 3/20ths, is that greater than 0? Yes, it's 3/20ths greater than 0. Is it less than half? Half would be anything that has half the number on the top on the numerator as the denominator. So 10/20 would be half. This equals 10/20. So what we can do is realize that 3/20 would be in this region, and it's quite a bit less than half, so it'd be somewhere around here. So let's put 3/20 there. Then 22/40. What would a half be? It would be 20/40. Is 22 bigger than 20? Yes, it is. So we can put 22/40 here. I meant to draw an arrow here. 19/20. This is almost 20. This is almost as big as this, and it's nowhere close to 10. It's much closer to 20. So 19/20 would be somewhere over here. So we would know that this would be the order from least to greatest. So least to greatest, remember, always check. Sometimes I might put greatest to least. It's 3/20, then it's actually 22/40, and then it's 19/20. Okay? We put it in order, and we put commas between from least to greatest, and that would be your answer. I like using method 1, the benchmarks, for estimating. But there are a couple other methods that I find more successful getting exact answers, especially when you have a lot of numbers to organize. One of them is method 2, I call it, which is finding a common denominator. So here we have one fraction, 7/8. Then we have an improper fraction, 9/8. Then we have 1 and a quarter, which is a mixed fraction. There's a whole number and then a fraction. Then we've got a decimal. So we've kind of got the four different things that we might see. There's percents maybe later on in the unit. But now we need to put these in order by using a common denominator. So what we need to do first is change these a little bit. We're going to find a common denominator, which means that we're going to be using fractions, which means any decimals we're going to need to change. And this is a way that I'd like you to show it. You can write down your fractions. That's your first step. And we're going to be, let's do from greatest to least this time. Okay. First thing, write down your fractions and your decimals in order. Keep it the same order as a textbook. And then any of these that you need to change, you're going to do. So 0.75, we're going to change so that we've got a denominator. What fraction is this? We know that this is 75 hundredths. Okay. And then we're just going to draw little arrows that we're just going to carry this through. We're not going to change this at all yet. Now, thinking, what denominator could we make all of these be? The first one here, we've got 1 1/4. We need to change this so that it's not a mixed fraction. So if we have 1 1/4, that means we have a quarter, and then 1 is the same thing as 4 quarters. We've got 4 quarters plus 1/4. We would have 4 plus 1 is 5 quarters. Okay, so there we've got 5 quarters. This is still carrying through. It's still the same. It's still the same. 75 hundredths. How many quarters is that one? Okay, that would be 3 quarters by dividing by 25. Okay, so we changed those ones. We're at quarters. This is still at 9/8. This is still at 7/8. Now 8 1/4, the easier way is to go to a bigger denominator because you won't run into any problems. If we try to go down to having a quarter that we're going with, 9 can't divide by 2 easily. You'd end up with a decimal over a fraction, and that doesn't work. So we need to take this and we're going to bring it back up. We're going to multiply it by 2. This one we're going to multiply by 2, and we're going to be left with 6/8. 3 times 2 is 6. 4 times 2 is 8. 5 times 2 is 10. 4 times 2 is 8. Then we've got 9/8 still, and we've got 7/8. Now we need to put them in order from greatest to least. So now that we have the same denominator, all we need to do is look at our numerator and put them from greatest to least. Which is the greatest numerator? 10 is. Okay? So that's the one that goes first, 10/8. Then the next, 10/9. Put a comma, 9/8. Then 7/8. And then 6/8. But it asked us to put these fractions and these decimals in order from greatest to least, which means we need to write these exact ways. Okay? So wherever you see 10/8, remember 10/8 was 1 1/4, so we need to write this 1 1/4. That's the biggest one. Then 9/8 was our next, so 9/8, which one's 9/8? Oh, it's still 9/8. Our next one is 7/8. 7/8, it was still 7/8. And then 6/8 originally was written as 0.75. So those ones rearranged so that they're in order from greatest to least would be this right here. So the ones that are written in your textbook or in the question, those are the ones that you should order. So always put it back to that once you've figured out what the order is. So the third method we'll be using is using decimals. So it would, in this case, I wouldn't use this method, but we're going to do the same question to show how to do it. It would be changing everything to be decimals. So this method, we change everything to a decimal. So we've got 7/8. So we need to take 7 and divide it by 8. I remember, and I have it memorized, that 0.125 is 1/8. And if I multiply that by 7, I would get to 7/8. Or I could subtract 0.125 from 1, and I would end up with the correct fraction. Another way would be to use some long division on the side to figure this out. So I did the long division on the side. 7 divided by 8 is 0.875, which happens to be 0.125 less than 1. 9 over 8 is the same thing as 8 over 8 plus 1 over 8, which would be 1, and then 1/8, which is 0.125, which means that this would be equal to 1.125. We could do long division as well. 1 1/4 would be 1 decimal and a quarter. Remember, it's 25 cents, so it's 1.25. And then we already have 0.75. Then what we can do is compare using place value. Whichever has the biggest value in the leftmost place, so in our units place, is the first thing. So it's going to be one of these two would be the greatest. And then we compare the tenths, the next place over, 1 and 2, which is bigger? 2 is. So 1.25 would be the biggest, the greatest. And then it would be 1.125. And then we need to compare these ones. We have 0 in our units, but our next we have 8 and we have 7. 8 is greater, so it's going to be 0.875, and 0.75 is our final number. And then we need to put them back into their original values. So 7/8 was, sorry, not 7/8, 1.25 was our 1 1/4. 1.125 was our 9/8. 1.25 was our, sorry, where am I? Here we go. 0.875 was our 7/8. And 0.75 was just written as 0.75 to begin with. So there would be our answer. So if you find decimals easier to work with, maybe you want to switch to decimals. If you find fractions easier with a common denominator, go that way. Or if it's benchmarks that you can see very easily, use benchmarks. I would probably have used fractions in this way just because I'd only have to change one to fractions. Whereas if I had a lot of decimals and only a couple of fractions, I'd go the other way.